Today I'm going to be discussing the Oregon Mountain sediments, more specifically in the Precambrian and Paleozoic eras. Before discussing the Paleozoic era, let's discuss the deposits during the Precambrian era, which were mainly exposed on the eastern part of the Oregon Mountains. The predominant rock is going to be granite, which you'll have three different types that can vary from porphyritic to highly porphyritic and colors from browns to grays, pinks to reds, or brown from weathering. You'll also find different dikes and intrusions of pegmatite and apatite through the granite. These Precambrian rocks will underlie beneath the Bliss Sandstone, which is the beginning of the Paleozoic era. To my right are some examples of some of the pegmatite and apatite dikes that you might think you can find in the era. These aren't photos that are actual found in the era, just something that are kind of similar. The Paleozoic era is broken up into 7 different groups. You have your Cambrian, Ordovician, Silurian, Devonian, Mississippian, Pennsylvanian, and Permian. The oldest of the groups are going to be the Cambrian and the Ordovician, which are composed of the Bliss Sandstone, the El Paso group, and the Montoya group. Beginning with the Bliss Sandstone, which overlays on the Precambrian in a nonconformable way, is located on the eastern of the southeast ridge of the Oregon Mountains. These colors can vary from top to bottom, from being dark to almost black, and the top being light to gray to almost orange from weathering. Some traces of sandstone have led to believe that there might have been some sea transgression over the peneplain over time. Next is the El Paso group, which is the beginning of the early Ordovician era and also the beginning of the Dolomite series. This group is exposed on the south and northern ends of the Oregon Mountains. Colors vary distinguished to limestone to dolomite. A good way to identify this group is to see if there is any brown reticulating marks of seaweed. You may also find this group among calcic beds. Next is the Montoya group, which is overlaying the El Paso group and is exposed at Target Range and Black Prince Canyon. This one is broken up into 4 major formations. You have the Cable Canyon Sandstone, Uphand Dolomite, Alaman Dolomite, and the Cutter Dolomite. The first 2, which are composed of sandstone coarse-grained and dark gray weathering coarse crystalline thick bedding of dolomite. The bottom 2, which came later, are the uppermost and they're shirt-free. The next era is the Silurian era, which begins with the Montoya formation breaking up into the Fusselman Dolomite. You'll have 2 types of units, your upper unit, which is hard and dark, and your lower unit, which is fine-grained. The lower unit is going to be light gray, pearly, and coarse-grained, which you'll see a lot more in the area. The upper unit, which is not seen in the area at all, is going to be a more rusted dolomite, and it will have some yellow and tan to it. To the right, you'll see some images similar to the dolomites that you might see in this series. With these formations, there is much thinning due to Devonian erosions. The Devonian era, which overlays the Silurian formations, is made up of the Canotile and Percha formations. These are also known to be non-fossiliferous from black to gray shales. Each of these 2 members also have sub-members beneath them. With the Canotile, you'll have the lower unit of a dolomite siltstone and the upper unit of a shirty limestone and dolomite. In the image below, you'll have something that's similar with the yellow and brown colors. Then you have your perchas, which of the lower is a black fissile shale, and the bottom is a shale with limestone nodules. The percha is also known to be easily recognized due to the fissile shales. Next is the Mississippian, which overlays the percha shale. This one is only exposed at the Bishop's Cap and has 5 major formations. You have the Caballero, the Lake Valley, Las Cruces, Rancheria, and Helms. The Caballero has an abrupt change and indicates disconformity. This one has a contact with underlying percha and varies from north to south. The Lake Valley is a more complex one because it has rapid thickening and thinning throughout the area, and there's also irregular erosion. With this one, you'll have 6 different submembers. You'll have the Andresito, Alamogordo, Nune, Terra Blanca, Arcante, and Donna Ana. In the Las Cruces, it lacks shirt, and the upper content isn't conformable. You'll see this one with light gray, even bedding on the limestone of the Devonian. The Rancheria, which overlays Las Cruces, underlines the lead cap, which you'll see in the Pennsylvania. This one is also easily identified and is distinguishable with 4 different factors. If it has abundant shirt, interlayered black micrites, brown weathering, and thin banded appearance. The last one is Helms, which has an abrupt change which indicates disconformity as well. This one has contact with underlying percha, and this one as well varies from north to south. In these images are different examples of how these different eras are laid around throughout the region. In these images, you'll have examples of the Middle Paleozoic rocks. Lastly, you have your Pennsylvanian and Permian era, which are exposed throughout the area. With these, you'll have sturdy fossiliferous siltstone and micrites. This era reflects a huge change in the environment, and this one is composed of 7 different members: the lead camp, La Tuna, Barrino, Panther Seep, the Hueco limestone, Abo and Yeso, and San Andres. The first one is going to be lead camp, which is going to be the oldest of the 7. It overlies the Rancheria and is distinguished by the massive gray limestones or dolomite cliffs. This one also transitions into the Panther Seep. Next is La Tuna, which is distinguished by the massive gray limestone by the Helms Shale. This one is recognized at Bishop's Cap and the weathering shirt in the limestone. Next is the Barrino, which overlays La Tuna in a conformably manner. You'll notice this one by its thick shale red color, and the upper beds form the Bishop's Cap's peak. Next is the Panther Seep Formation, which is conformable between the lead camp and the Hueco. There's a variety of weathering colors with this one. There's also 4 layers, 1 of gray shale, 2 which is most calcareous siltstone, 3 which has an abundance of platy laminate and brown weathering micrite, and 4 which has more shirt but less laminated. Next, you'll have the Hueco limestone formation, which has 3 informal members. The first one, which is the lower underlying conformal with the Panther Seep, the second, which is bedded with shale, third one, which is the siltstone beds of the Abro. This one is also known to be called the Abro Hueco. The next formation you'll have is the Abo Yeso, which are red beds that you'll find near the Love Ranch Mountain in the area. These colors will vary from red to brown, and there is a variety of interbedded shales. Also, there is no gypsum seen in this formation. The last formation you'll have is going to be the Yeso San Andres, which overlays the Abo, this one is mostly limestone and also has a variety of colors when weathering. In this formation, you'll have quartzite and sandstone that lay unconformable on the limestone. This is the correlation of the Mississippian Formation between the southern San Andres Mountain and Bishop's Cap. Some of the things that I have mentioned throughout are seen in this chart. This concludes my presentation of the Oregon Mountain sediments leading up to the Cretaceous era. Thank you.